So these notes are going to go over inverse functions of trigonometric ratios. So we're still going to use sine of whatever the angle is, which is opposite over hypotenuse, cosine of whatever the angle is, which is adjacent over hypotenuse, and then tangent of whatever the angle is, which is opposite over adjacent, right? All right, next we need to start understanding how to use side lengths to find angle measures. So they'll give you the name of some triangle and say find, let's do x, let's just do x. Say find angle x in degrees, clearly, right? So we need to take out our calculators, hit mode, and make sure that our calculators are in degrees. Okay? So on your calculator, hit mode, go down to radian degree, and make sure it's in degrees. Press enter, and then you can get out of it. Okay? So we're going to use those to help us find. So if I am given, let's first identify some things. Across from the angle of interest, which is x, is what? Opposite. Good. Over here, what is this one? It's the hypotenuse because it's directly across from the 90-degree angle. Therefore, what is this side? Adjacent. Good. So if this side is 10 and this side is, let's say 15, I know the opposite and hypotenuse. So which one am I going to use? Sine, cosine, or tangent? Sine, right? Since sine deals with opposite and hypotenuse, I'm going to use sine. So here we go. Sine of the angle, which is x, is opposite, which is 10, over hypotenuse, which is 15. Now, if I said, what is the inverse operation of addition, you would tell me what? Subtraction. What is the inverse operation of multiplication? Division. And they work in vice versa. So here, when I say what is the inverse of sine, you're going to tell me sine inverse. Okay? So we're going to call it a multiplication, but sine inverse on your calculator looks like that, sine to the negative 1. So that cancels out that sine. But what we do to one side, we must do to the other. So we get sine to the negative 1 of 10/15. Now, if you want to reduce that fraction, you could, but your calculator is going to deal with it all the same. So everybody get out your calculator. We're going to hit these buttons. Second sine, that gives us sine to the negative 1, which is sine inverse. Open parenthesis, and then we just enter what's inside of our parentheses, 10 divided by 15. So 10 divides 15, and then we just press enter. Depending on what our worksheet tells us to do, we'll round accordingly. But without a specified thing to round to, we're going to round to how many decimal places? 4. Somebody say 4. Awesome. Okay, when dealing with sine, cosine, and tangent, we want to round to 4 decimal places. Okay, unless otherwise specified. I think your worksheet says round to the nearest degree. So if we rounded this one to the nearest degree, it would be 42. Okay? So the answer would be sine inverse of 10 over 15 is 41.81. I'll round it to the hundredths there. And then, since I'm rounding it to the nearest degree, I'd put 42 degrees. So if x is 42 degrees, what will this one up here be? Let's call it y. Okay? So I'm looking from y, and I'm looking across from y. I'm going to erase all of my labels because now they don't apply, except for hypotenuse. Hypotenuse stays the same no matter what. But now I'm looking from y. If I'm looking across from y, what's across from it? We're going to do it the long way, Kara. What'd you say, Cole? No, we wouldn't, but we're just doing it to have another example. What is across from y? Opposite. Okay, hypotenuse stays the same, so what would the 10 be? Adjacent. So what uses adjacent in hypotenuse? Cosine. So I have cosine of y is adjacent, which is 10, over hypotenuse. Again, so I do the inverse of sine to both sides. So those cancel out, and y will be whatever cosine inverse of 10 divided by 15 is. So second cosine inverse of 10 divided by 15 Oh, I didn't do inverse, sorry. Thank you for the catch. There we go. 48.189, blah, 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 blah. Okay, so rounding to the nearest degree is 48 degrees. So y is 48 degrees. Now, Kara said, right before we even started, well, it's 48. How did you do that, Kara? So she said 90 and 42 added together, subtracted from 180 would give her 48. There's another easier way to do that, just so you deal with smaller numbers. You know that since this is 90 degrees.
45 and 45 are 90, so 42.
Right. So these two angles always add up to 90 because this is a right triangle. So since these two are going to be 90, we took 90 and subtracted it from 42, and we'd get 48. Now, yes, of course, that would be the easier way to do this. I'm just doing examples with the inverse so that you can see it. Okay? Is that what you saw too, Cole? Okay. So let's do another example. I'm going to draw this one upside down. I'm going to call this angle K. Over here, I am going to have 5. Over here, I will have 8. Of course, this is a right triangle, otherwise I wouldn't be able to do anything with it. With the knowledge that I currently have, anyway. So, what is the 5 in relationship to K? It's opposite. Good. And what is 8? Adjacent. Leaving the only other thing there to be the hypotenuse, right? So, what deals with opposite and adjacent? Tangent. So I have tangent of K is opposite over adjacent, which is 5 over 8. I'm sure you've started to realize there's a pattern, right? All I have to do is multiply by the inverse. So long as you write down this first part, and I can tell you know what you're doing, you can go ahead and jump to the next step, which is really simple without doing both of these. So you would just simply go from this to tangent inverse of 5/8 is whatever our answer is, okay? So we'd be able to find out what K is, so let's do it. Second, tangent of 5 divided by 8. 32.00538, blah, 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 blah. Again, we're rounding to the nearest degree here, so it is 32 degrees. Okay, any questions of me, guys?